Math 1332, Chapter 3, Symbolic Logic, Section 4, Logical Arguments, Video 9, Common Fallacies, Fallacy of the Inverse. In the previous video, we discovered an invalid argument form called the fallacy of the converse. And the reason people fall for it is because they incorrectly assume that if you have an if-then statement, a conditional, that you can arbitrarily switch the order of it, in other words, form the converse, and everything's okay, except it's not, because a converse and a conditional are not logically equivalent. Well, neither are the inverse and a conditional. So does that cause problems? And the answer is, yeah, it does. Consider the following premises. Premise 1, if I get a pay raise at work, then I will take my family on vacation. Premise 2, I did not get a pay raise at work. Can you draw a conclusion, and is that conclusion valid? So what conclusion do you think people would draw here? Let's take a look at what our premises are. Our first premise is a conditional, no surprise there. If I get a pay raise at work, then I will take my family on vacation. Go ahead and highlight the simple statements contained in that conditional. The second premise is almost the antecedent, except it's its negation. The antecedent was I get a pay raise at work, and the second premise is I did not get a pay raise at work, and so it was the negation of the antecedent. So what conclusion do you think people draw here? Well, if they didn't get the pay raise, they probably concluded that they didn't take their family on vacation. That is the most common conclusion to draw, is I did not take my family on vacation. But is it possible for that conclusion to be false if both premises were true? Because remember, that's what we're really answering when we ask, is this argument valid? If the premises are true, does it imply that the conclusion must also be true? Well, think about it. Let's say I'm at work and I say to my family, I call them on the phone, hey, if I get a pay raise, then I'm going to take you on vacation. That's premise number 1. Premise number 2, I don't get the pay raise at work. Is it possible to still take my family on vacation? Of course it is, because there are several other reasons that could allow us to take a vacation. For example, maybe I won a trip in a contest. I was on my way home, radio station said 10th caller gets trip to Florida. I called in, I won the trip. And that's how I took my family on vacation, despite not getting a pay raise at work. So it's possible for the first premise to be true. It's a promise. I promise if I get a pay raise at work, I will take my family on vacation. For the second premise to be true, I did not get the pay raise at work. But the conclusion of not taking my family on vacation to be false because there are other things that could have happened. Plus, if you think about it, the conditional is only making a promise under the condition that I get a pay raise. I never said what would happen if I didn't. So why do so many people incorrectly draw this conclusion? Well, the answer lies in another variation of the conditional. Recall that the inverse of a conditional is formed by negating, that's my symbol for negating a statement, I don't know why. The inverse of a conditional is formed by negating the antecedent and consequent. For example, the inverse of if I get a pay raise at work, and let's highlight some of these things. If I get a pay raise at work, then I will take my family on vacation is, what would the inverse of that be? What would it look like if I negated both the antecedent and the consequent? It would look like that. If I don't get a pay raise at work, which is a negation of the original antecedent, so we'll highlight the part that makes it a negation, then I won't take my family on vacation, which again is almost the original consequent, but it's the negation. So that would be the inverse of the original conditional. Also recall that in general, the inverse is not logically equivalent to the original conditional, which means that the last columns in the truth table of P pointing to Q and the inverse negation P pointing to negation Q, those two statements, truth tables, last columns, do not match, and therefore they are not logically equivalent. Thus, you cannot arbitrarily replace a conditional with its inverse. But what if you did? So we're going to take a look at this argument, but what happens if I replace the first premise with its inverse? And it will look like this. If I don't get a pay raise at work, then I won't take my family on vacation. Premise 2, I did not get a pay raise at work. Conclusion, I did not take my family on vacation. Is that a valid argument? The answer is yes. Why? Look at the structure. The first premise is a conditional, highlighting the antecedent and the consequent. What is the second premise relative to the first premise? The second premise is the antecedent. And what about the conclusion? The conclusion is the consequent. Now, it's not the negation of the consequent because they both say won't or didn't. And the same thing with the antecedent and premise 2. They're not negations. They both say they don't or they did not. So no negations occurred when going from premise to conclusion. Does this argument form look familiar? Yes, or at least I hope it does. If you could replace the conditional with the inverse, then the conclusion would be valid because now it's the law of detachment. Go back and review it in case you forgot. But you can't replace a conditional with its inverse, so it isn't a valid conclusion and it isn't a valid argument. Because people incorrectly assume an inverse is logically equivalent to its original conditional, they draw an invalid conclusion in this situation. Hence, this invalid argument form is called the fallacy of the inverse. And here's its pieces. Common fallacy number 2, the fallacy of the inverse. The first premise is a conditional, so generically P pointing to Q. The second premise is not the antecedent, but the negation of the antecedent, and the conclusion is not the consequent, but the negation of the consequent. Now remember, this is an invalid argument form. So if an argument has this form, the conclusion is invalid. Doesn't mean the conclusion is false. It means the conclusion does not logically follow from that set of premises. The fallacy of the inverse also has a descriptive form. Shouldn't surprise you, every form prior to this has had one as well. That descriptive form looks something like this. We start with a conditional, if an antecedent, then a consequent, but the second premise is the negation of the antecedent, and the conclusion is the negation of the consequent. Has the exact same structure as the symbolic representation. Antecedent here, except it's the negation of the antecedent. And then the consequent from the first premise is almost the conclusion of the argument, except it's the negation of that consequent. Let's take a look at an example in words. Determinate the following is a valid argument. Premise 1, if my cat gets spayed, then she will not have kittens. Premise 2, my cat did not get spayed. Conclusion, my cat will have kittens. A lot of people would say, well, naturally. But does this conclusion logically follow from the two premises? Must this conclusion be true if the two premises are true? Let's analyze the structure of the argument. The first premise is a conditional, and you'll notice a lot of these common argument forms start with a conditional, so get ready to go antecedent, consequent, and where else are you? The antecedent of the first premise is my cat gets spayed. The consequent is she will not have kittens. What is the second premise relative to that antecedent or consequent? The second premise is almost the antecedent, but it should be pretty clear that it's the negation of the antecedent. And what about the conclusion to the argument? The conclusion, my cat will have kittens, is almost the consequent, except it's the negation. Now, this is an instant where it looks like a backwards negation because the not is up here. But remember, to form the negation of a statement, you take a similar statement with the opposite truth value. And in general, you usually form a negation one of two ways, by putting in the word not or taking out the word not. In the case of the consequent, the green statement, we formed its negation by removing the word not, and that's what the conclusion is. But this is precisely this. I know the reds are in different places, but that's just the location of the word that indicates a negation. The second premise is the negation of the antecedent. The conclusion is the negation of the consequent. Same thing here. The second premise is the negation of the antecedent. The conclusion is the negation of the consequent. This is precisely the fallacy of the inverse. Thus, the argument is invalid. Let's take a look at one symbolically, and then we'll wrap up this video. Determine if the following argument is valid. Oh my gosh, look at all those letters. But the thing about this argument that says, wait a minute, this might be a common argument form, is the fact that the first premise is a conditional, which has an antecedent and a consequent. So let's track them down. In the first premise, the antecedent is R biconditional negation Q. Do you see that statement elsewhere? It is right here in the second premise, but it's not exactly that. It is its negation. Now let's look at the consequent of the conditional, Q disjunction P. Do you see that elsewhere? Down here in the conclusion. But it's the negation. So is this the fallacy of the inverse? Look at this one down here. Look at the coloring. Now look at this one. Exactly the same. Antecedent pointed to consequent. Negation of antecedent. Negation of consequent. That. So, the argument is invalid by the fallacy of the inverse. I want to remind you that in any symbolic argument, you can always take the truth table method approach. This truth table would get a little bit crazy. Get down, dog. Get down. Sorry, dog's in the chair next to me. This one is a little crazy because of all the extra symbols. And as a truth table would be 8 rows deep, and I haven't counted the columns yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. 8 rows. Your truth table would have 80 T's and F's in it. So it's worth it to be able to look at an argument and go, wait a second, does this resemble a common argument form, by identifying its pieces? And if it starts with a conditional, those pieces start with the antecedent and the consequent. So let's wrap it up real quick. I say that a lot and don't always follow through. The fallacy of the inverse says the following is an invalid argument form. Symbolically, if your first premise is some antecedent pointing to some consequent, and the second premise is the negation of the antecedent, negation of P, and your conclusion is the negation of the consequent, then that is the fallacy of the inverse. Your argument is invalid. Same thing descriptively. If your first premise is some antecedent and then some consequent, and then the second premise is not the antecedent, but the negation of the antecedent and your conclusion is not the consequent of the conditional, but the negation of the consequent, then that is the fallacy of the inverse.